Hello, welcome to 5.2, the natural logarithmic function, this time integration. Last time was differentiation. So theorem 5.5, the log rule for integration says, let u be a differentiable function of x. The integral of 1 over x dx is the natural log of the absolute value of x. That's because the natural log of the domain is only for positive values, not for 0 or for anything negative. Plus c, of course, the integral for 1 over u du is natural log of the absolute value of u plus c. If it turns out that your function inside, if you're doing like u, and maybe u equals x squared plus 1, that's always positive. You don't have to worry about the absolute value bars. We tend to put them on just to be careful, just to be safe. Okay, because du equals u prime dx, the second formula can also be written as the integral of u prime over u du is natural log of u absolute value of u plus c. So for example 1, it says find the indefinite integral 10 over x dx. Well, that's going to be 10 times the integral of 1 over x dx, which is 10 times the natural log of the absolute value of x plus c. Okay, example 2 says find the indefinite integral for integral of 1 over 3x plus 2. So in this case, if I said u equals 3x plus 2, du would be equal to 3 dx. So 1/3 du equals dx. So we can rewrite this as 1/3 of the integral of 1 over u du. So let's see, the 1/3 du, that's my 1/3 du, that's the dx. So this becomes 1/3 natural log of the absolute value of 3x plus 2 plus c. Well, I'm kind of jumping steps there. 1/3 absolute value of u plus c, which is 1/3 natural log of the absolute value of 3x plus c. Not 3x plus 2 plus c. Now for example 3, find the indefinite integral. We have the integral of x squared plus 2x plus 3 over x cubed plus 3x squared plus 9x dx. So if I said u was the derivative, or the denominator, my du would become 3x squared plus 6x plus 9 dx. And what I want to point out about this, if you factor a 3 out, du equals 3 times x squared plus 2x plus 3. This is the numerator. So 1/3 du equals x squared plus 2x plus 3 dx. This is what we have up there. So now we can write 1/3 integral 1 over u du, which is 1/3 natural log of the absolute value of u plus c, which is 1/3 natural log of the absolute value of x cubed plus 3x squared plus 9x plus c. Let's go on to page 2. Example 4 says find the indefinite integral by using u substitution. Give us a hint. It says let u be the denominator of the integral. Okay, let's see what happens with that. If I said u equals the square root of x minus 3, I have just the square root of x up here, so u plus 3 would be the square root of x. Now what about du? Du would be equal to 1/2 times 1 over the square root of x dx. So du would be equal to 1 over 2 times the square root of x dx. Now I don't have 1 over 2 times the square root of x dx. So I'd have to say, okay, I do have this up here, but that's not quite the same thing. So 2 times the square root of x du equals dx. So 2 times, and square root of x is, we can say u plus 3. So here's our substitution we're going to make. We're going to have the integral, this square root of x right here, make that substitution, u plus 3, over, this is just a u, times our dx is 2 times u plus 3 du. So we're going to end up with 2 times the integral of u plus 3 squared over u du. That's 2 times the integral of u squared plus 6u plus 9 over u du. That's going to be 2 times the integral of u plus 6 plus 9 over u du. So we end up with 2 times the integral of u du plus integral of 6 du plus integral of 9 over u du. That's 2 times u squared over 2 plus 6u plus natural log, 9 times the natural log of the absolute value of u plus some constant c. If I distribute that 2, we're going to have u squared plus 12u plus 18 times natural log of the absolute value of u plus c. And then if I substitute back, we end up with the square root of x minus 3 squared plus 12 times the square root of x minus 3 plus 18 times the natural log of the absolute value of the square root of x minus 3 plus c. And we can go one step further if we really wanted to. Squaring this out, x squared is a minus 6 times the square root of x plus 9 plus 12 times the square root of x minus 36 plus 18 natural log of the absolute value of the square root of x minus 3 plus c. And we have x squared negative 6 square root of x plus 12 square root of x is going to be plus 6 times the square root of x. 9 minus 36 is minus 27. And then we have plus 18 natural log of the absolute value of the square root of x minus 3 plus c. Okay, well, that was kind of a fun one. Okay, I'm going to go on to example 5. Feel free to pause if you'd like to pause. Okay, so let's find the indefinite integral. You may have to use long division first. That's a hint. So let's do long division. X minus 3 goes into x cubed minus 3x squared. Don't see an x, so it says 0x plus 5. X times what is x cubed? I'll say it's x squared. So it's x cubed minus 3x squared. That's kind of handy. It's nothing. And then we bring down a 5. That's the remainder. So this is going to become the integral of x squared plus 5 over x minus 3 dx. So this is the integral of x squared dx plus 5 integral 1 over x minus 3 dx. This is x cubed over 3 plus 5 times the natural log of the absolute value of x minus 3 plus c. That's it. So let's go over the guidelines for integration here. This is learn a basic list of integration formulas, including those given in this section. You now have 12 formulas, the power rule, log rule, and 10 trigonometric rules. By the end of this chapter, the section 5-7 that we cover, this list will expand to 20 basic rules. Find an integration formula that resembles all or part of the integrand, and by trial and error find a choice of u that will make the integrand conform to the formula. If you cannot find a u substitution that works, try altering the integral of the integrand. You might try trigonometric identity, multiplication and division by the same quantity, or addition and subtraction of the same quantity. Be creative. If you have access to computer software that will find antiderivative symbolically, use it. And in that, I'd say the TI-89 does a great job. Also, there's a website, I think it's Wolfram Calc. I think that's what it is. I'll look it up, make a link for it. Okay, example 6. Find the indefinite integral. We have the integral of cosine of theta over sine theta. Now, I'm thinking natural log stuff, so if I say u equals sine theta, my du would be cosine theta d theta, and I have that. This would be the du. So I'd have the integral of 1 over u du, which is the natural log of the absolute value of sine of theta plus c. I'm sorry, I get excited and I skip steps. Absolute value of u plus c, natural log of the absolute value of sine theta plus c. Okay. Integrals of the 6 basic trigonometric functions. Sine of u du integral is going to be negative cosine u plus c. We've seen these. Integral tangent u du is negative. Sorry, we haven't seen this one. Negative natural log cosine u, absolute value cosine u plus c. And then integral secant u du is natural log of secant u plus tangent u plus c. Integral cosine u du is sine u plus c. Integral cotangent u, and this would have been a cotangent, is natural log of the absolute value sine u plus c. And integral of cosecant u du is negative natural log of cosecant u plus cotangent u plus c. Example 7. Solve the differential equation passing through 0, 4. So this is our initial condition. So dy dx equals 2x over x squared minus 9. That means y equals the integral of 2x over x squared minus 9 dx. And that would be, now this is my u is x squared minus 9, du would be 2x dx. So this is the natural log of the absolute value of x squared minus 9 plus c. Now we know that whenever x is 0, y is 4, so y of 0 equals the natural log of the absolute value of 0 squared minus 9 plus c, and that's 4. So this is natural log of the absolute value of negative 9 plus c. Natural log of 9, because the absolute value got rid of the negative, plus c is 4. So c would be 4 minus natural log of 9. So our function is y equals the natural log of the absolute value of x squared minus 9 plus 4 minus natural log of 9. Let's go on to example 8. Example 8 says evaluate the definite integral. Use a graphing utility to verify your result. So we have the integral from e to e squared of 1 over x natural log of x. Now, think of it this way. We have the integral from e to e squared of 1 over natural log of x times 1 over x dx. I do that because if I say u equals the natural log of x, du would be the derivative of natural log of x, which is 1 over x, then our dx. And we have that. This part is my du. So I have the integral from, I'll say, u of e to u of e squared. I haven't shown you one like this in this way to do it before, of 1 over u du. And that becomes natural log of the absolute value of u from u of e to u of e squared, which is natural log of the absolute value of, well, let's go back now and substitute. That's natural log of, what was u? U was natural log of x. So natural log of x from e to e squared. So that's natural log of e squared minus natural log of the natural log of e. So that's natural log of, well, natural log of e squared is just 2. Natural log of e is just 1. So it's natural log of 2 minus natural log of 1. That's natural log of 2 minus 0. And we just have natural log of 2. Okay, I'm going to go on now to the last page. A couple of examples there. Look at example 9 first. Find the area of the region bounded by the graphs of the equations. Use a graphing utility to verify your results. So we want, this is our function here, x plus 4 over x. It's a curve like this. X going from 1 to 4. So we have the integral from 1 to 4 of x plus 4 over x dx. Now if we divide it here, that's the integral from 1 to 4 of x over x plus 4 over x dx, which is the integral from 1 to 4 of 1 plus 4 over x dx. And that's the integral from 1 to 4 of just 1 dx plus the integral from 1 to 4 of 4 over x. Let's pull it 4 out front. 4 times 1 over x dx. So we end up with x from 1 to 4 plus natural log of the absolute value of x from 1 to 4. That's 4 minus 1 plus natural log of 4 minus natural log of 1. That's 3 plus natural log of 4 minus 0. So 3 plus natural log of 4. That would be approximately 8.5452. Okay, got one more problem to do here. Example 10. So let's find the average value of the function over the given interval. That from chapter 4. It's 4:4. F of x equals 4 times the quantity x plus 1 over x squared from 2 to 4. So we have 1 over 4 minus 2 integral from 2 to 4 of 4 times x plus 1 over x squared dx. That's going to be 1 over 2 times, I'm going to pull this 4 out, integral from 2 to 4. And we have x over x plus 1, x over x squared plus 1 over x squared dx. Now, 1/2 of 4 is 2, so that's 2 times the integral from 2 to 4 of 1 over x plus 1 over x squared. Now the antiderivative for 1 over x is natural log of x, and the antiderivative for 1 over x squared, well, that's like x to the negative 2 power. So we add 1 to get negative 1 power, divide by the new power, so that's going to be plus 1 over x divided by negative 1 from 2 to 4. So we have 2 times the natural log of 4 minus 1 over 4 minus natural log of 2 minus 1 over 2. That's natural log of 4 minus 1/4 minus natural log of 2 plus 1/2. If I multiply the 2, well, let me do this one more step. 2 times natural log of 4. Now natural log of 4, isn't that going to be, that's 2 squared. So that would be 2 natural log of 2 minus 1/4. I'm going to do minus natural log of 2 plus 1/2 minus 1/4. So we have 2 times what? 2 natural log of 2 minus natural log of 2 is just natural log of 2. 1/2 minus 1/4 is 1/4. If we multiply through by 2, we have 2 natural log of 2 plus 2/4. That's 2 natural log of 2 plus 1/2. You could also write that as natural log of 4 plus 1/2. And that would be approximately 1.8863. And that's the end of 5.2. Hope you enjoyed that. Hope you're liking this stuff. Getting near the end. Thank you. Talk to you guys later. Send me your questions. Bye.